So I will be happy to record the session. In most of the cases, I'm going to be going through many Excel examples. So it might be good to watch, or what I can do is I'm going to go through the lecture, record it, stop it, and then start another recording so I can do the examples in Excel. So you don't have to be watching the whole thing just for one or two procedures. So I'm going to start reading and going through the ideas. At the end, I'm going to finish and then restart a new recording for our Excel assignment. So what is statistics? So why are we here? So, well, that's a very good question. Many people need statistics. Statistics is about information, but it's not only about information, it's about how you present the information. So you can have beautiful numbers there, but if you cannot make sense of the numbers, that doesn't help. So statistics is very good to let people know what is the importance of those numbers. For example, if I say the number of women or women are, or the percentage of women is higher at Lehman than the percentage of men. So that might be interesting because I need to know what is that percentage. So probably that there are a 60 versus a 40, or a 59 versus a 51 versus 49. So we need to know, and the data can help a lot. But also remember that the statistics can serve many purposes. If you see the news, the president says something and then somebody else says something different. So who is right and who is wrong? Well, we need to look at the numbers because they are making a point based on the numbers. So you can say that something is true based on the numbers, or you can also say that something is not true based on the numbers. So it's always up to us to deliver the information the best way we can, because statistics is a science, and the purpose of this science is to inform people to make good choices. So, so the science of statistics deals with the collection. So from collecting the data, before collecting the data, we have to design the collection. So we're going to talk a little bit about this because even the collection of data, there are many requirements. One of them is that the data is randomly selected. So that avoids the biases that this process can bring. So also, it's not only collecting the data, but analyzing the data and making an interpretation. And not only the interpretation, but how you disseminate that information. So the presentation of the data is very, very important. So, so when we have data, let's say that we have information from a hospital. So let's say that COVID was, information on COVID-19 was collected at Columbia Presbyterian Hospital. So what can we do with this information? Well, we can present the number of people who died, the number of people who recovered. So we are gonna try to find the most basic information in that data. So that organizing and summarizing data is called descriptive statistics. So we're gonna describe the data. So that bunch of numbers that are in certain database are gonna make sense for people who died more, men or women, older people, younger people. So that descriptive statistic is gonna be very, very important. We can create values like the mean, the standard deviation, or we can create graphs and some other types of data visualization that helps people better understand the information. So two ways to summarize the data are by graphing and by using numbers. So when we use numbers, basically we present those numbers on tables. Like for example, we can present the number of cases in New York City of COVID. We can present the number of cases divided by or stratified by gender, men and women. We can also present the data in terms of age age categories: young people, not too young, older, and super older people. So, so those ideas are very important, and that is called descriptive statistics. So also we can depart from other methods. So, so we can use the so-called inferential statistics to determine how confident we can be that our conclusions are correct. For example, somebody tells me that men have a 60% chance of dying from COVID compared to women, 40%. So I might be puzzled by this finding. So I cannot access the data, all the data. So what I'm gonna do is I'm gonna find a sample, and that sample is gonna yield information that is gonna be very important. But the problem is samples are small representations of the population. So how can I do it? Well, I'm gonna use a statistical method that is called inferential statistics. So I'm gonna use the sample to approximate the values of the population. So one of the most important tools that we can use in all this process is gonna be the concept of probability. So probability is a mathematical tool used to study randomness. So we are gonna look at several cases. In fact, chapter 4 or 3 or 4 is dedicated to probability. So most of the inferential statistics that we're gonna be analyzing is gonna be based on concepts of probability, okay? So, so we are gonna use these concepts to understand inferential statistics. So this is also very important in our study. We're gonna capture two different levels. So one is the population level and the other one is the sample. So the population is a collection of persons, things, or objects under study. For example, if I want to study political parties, for example, my population might be the number of Democrats in New York City, in New York State or New York City. So that's gonna be my population. But I cannot analyze all the people in New York City, and even worse in New York State, and almost impossible in the United States. So what I'm gonna do is I'm gonna use a sample. So I'm gonna take a little proportion of that population and I'm gonna analyze it. So, so to study the population, we also, we select samples. So the idea of sampling is to select a proportion or a subset of the larger population and study that proportion to gain information about the population. So very likely, so we're gonna use the concept, as I mentioned before, of probability and apply the concept of inferential statistics. So, so when we are talking about populations, any measurement related to population is gonna be called parameter, right? So populations are, so the way to describe the values of certain populations is by the concept of parameter. And when we are using samples, that concept is going to be called statistics. Let me give you an example. I want to measure the mean value of my population. So this mean value is going to be a parameter. But I can also measure the mean value of a sample. So that sample mean is going to be a value that is called statistics. So we have to be very, very careful about this, because in many cases we have to use the population mean, and in other cases we're going to be using the sample mean, or we can be using sigma, that is going to be the standard deviation of the population, and in other cases we're going to be using the standard deviation of the sample, and that is a value known as a statistic. Okay, so we have to be very careful. We have to understand very likely population parameters are going to take values expressed in Greek letters like mu for the mean, sigma for the standard deviation and sigma squared for the variance of the population. So when it comes to the sample, we are going to use the X with a little bar on top. So X bar means sample mean. The S is going to be the standard deviation of the sample, and the S squared is going to be the standard deviation of the sample. So we are going to be more familiar with this when we reach chapter number 2. So we have plenty of time to learn those concepts. My goal today is to alert you that population parameters are going to be different from sample statistics. Population parameters, of course, relate to the whole population, and statistics refer to those values obtained from the sample. So the accuracy of these estimates depends on how well the sample represents the population. And that is a big challenge. So how can I ensure you that my population is randomly selected and is representative of the sample? So if the sample, is a representative sample, what if the sample is not representative? So that is going to be a big problem, because my values, my results are going to be biased. For example, I want to measure the GPA for students at CUNY. So I am very smart, and I want to show the president that our students at CUNY are very smart. So I go to the honors college, and I take a sample of students by GPA. Of course, my sample is going to reflect that the mean value of the GPA is going to be 4.0. So these kids go there with a very high score. So that is a biased sample. So there might be some other ways to be more realistic about the representation of the sample. So we have to keep an eye on that. So we also have these concepts available. So, so those are noted with capital letters, such as X and Y, and is a characteristic of interest for each person or thing in a population. So variables are values that we are going, or are attributions for some attributions of things that we need to understand. For example, we can have variables that are numerical, or variables that are categorical. So numerical, very easy, they are expressed in numbers. So a numerical variable takes values with equal units, such as weight in pounds and times in hours. So if you are looking at the weights of 50 people, so you are going to find these variables that are expressed in numbers. However, we also have these categorical values. Those are more expressing attributions of the entity that we want to study. For example, political affiliation, eye color, gender, ethnicity. For example, I have a database with patients who are diabetic. So very likely numerical values are going to be the value of cholesterol, the value of CD4, some of these that can adopt a number. But the categorical values are going to be the labels that I am going to be using for those particular cases. So categorical values, as I mentioned before, so examples are political affiliation, eye color, gender, ethnicity. I want to measure cholesterol by ethnicity. Well, I'm going to break down my categories into different variables. So I'm going to use two categorical variables, probably whites and blacks, or white and Hispanics. So so that's the idea. So we have numerical values that are going to be able to be measured, and categorical values that serve mostly as labels. So the data are the actual values of the variable. So I identify the weights. So my subject number one, I go ask the person, how much do you weigh? The person says 50 pounds. Okay, so that is a data point. So data point are the actual values of the variable. So this data point is going to have a numerical variable, or it's going to be part of the numerical variable because it's something that we can measure, like weights, and it's going to be related to a category. Like, for example, a person with certain race, ethnicity, gender, or some political affiliation. So, so also we have this categorization of data. So as we have two different type of variables, numericals and categoricals, so we can talk about two different type of values or two different type of data. One is the qualitative data, which is the result of categorization or describing attributes of a population, like hair color, blood type, group, ethnic group, the car that a person drives, but also we have the quantitative data. So basically we are reaffirming these two different concepts. So we are defining them as qualitative data when they represent the attributes of that population, and the quantitative data, which is the numerical values that particular variable adopts. So, so this quantitative data is going to be even more interesting because, well, quantitative data are the results of counting or measuring attributes of a population. So how much money you have in your pocket today, how much is the pulse rate. So those are numbers that we are attaching to this qualitative value. So let me, just give me 1 second. So so we have qualitative and quantitative values. So remember, qualitative once again are labels, and quantitative data are the actual values. So we have some examples, I guess, later on. So quantitative data, that's even, well, that is very interesting too, because based on this categorization, so this quantitative data can be further categorized into different types. The one that is discrete and the one that is continuous. So data that are the results of counting are called quantitative discrete data. For example, if I say there are 50 students in the classroom, so of course I have 50 students, I cannot have 50 and a half. So quantitative discrete data adopts very particular numbers. So if you count the number of phone calls, for example, you are working as a receptionist, so your boss asks you how many calls did you receive today? Well, there were 20 calls. So, so that is a discrete value. So those are countable and numerical values. So, and this data take only certain numerical values, as I said. So it can be 20 calls, 30 calls. Somebody can ask you how long did the 15th call last? Oh, that lasts 20 minutes. So probably, so the point I'm trying to make, quantitative discrete data adopts very specific numbers. So, and that is different from the quantitative continuous data. So this is more values in the interval. For example, I have my car is filled with 20 gallons of gasoline. I mean, I don't know, I'm just saying something. So my car can be filled with 20 gallons of gasoline, but how much gasoline do I have? Well, probably I have 15.5 or 15.7. So in this case, the thing is very hard to measure accurately. So, and the values goes in the interval. For example, I can have 15.5, 17.75. So any value in the interval is going to be considered a continuous data point, okay? So we have this because we have different distributions for these values. So we have discrete distributions and we have continuous distributions. For example, an example of a continuous distribution is going to be the normal distribution. So we are going to spend a lot, some time analyzing this type of continuous data. Okay, so just keep in mind that quantitative adopts very particular values, and the continuous adopts many values in the interval. So for example, measuring the height of athletes in centimeters might result in such numbers as 183, 172, 191, 191, and so on. So if I measure people from the shortest to the tallest, probably I'm gonna find many values in the in between. So I can measure the 15, so that is and that is a discrete value. But if I measure the heights, so that might be considered a continuous data point. Okay. So if you have questions, please let me know. So those are examples of how we can present the data. So of course, if you are the president, you are the supervisor of these two colleges, and you see the numbers, probably the numbers are not telling too much, but when you look at the percentages, very likely you are going to be more motivated to understand what is the meaning of these numbers. So 41% versus 59%, of course, that is something that I can understand, and 9,200 versus 13,296. So it's very hard for me to put these numbers in context. So data is very important. In this case, this number is informative. In many cases, percentages are going to be also informative. So we have examples of, well, in this case, qualitative data can be the number of qualitative data is the label that we are using for this. So full-time, part-time, those are qualitative data. And quantitative is going to be the numbers that we are computing here. So, so we have two different colleges. What can we do with this? Well, basically, we can create charts, we can create tables. So this table is very helpful. I want to go beyond, so I will present this table. So I have 59 and 40. So if my president, if the president of my college is sensitive to this information, he probably will say, oh, we have, like these guys, they have too many part-time students compared to the other one, right? So you can make comparisons, and you can look at this by using charts in this case. So, so we can use numbers, we can use charts, and in some cases we can have so many charts. For example, the bar chart or the bar graph, so that shows the two colleges in different categories, full-time and part-time. I'm able to see in this case that the number of students is very high in the ANSA and lower in Foothill, but also the number of students full-time are smaller than the one in the ANSA. So these bar graphs are very interesting. We have many ways to express it. So one example of this bar chart or one application of the bar chart is going to be the Pareto chart. So the Pareto chart basically shows me a bar chart that is going to contain the highest frequency in the first bar and the lowest in the last bar. So why is that? Well, I want to highlight the importance of these different categories. For this, so for this graph, I think ethnicity is very important. So you want to let your president know which is the largest ethnic group in your school, sure. So you can do that. So in this case, for example, in this school, so 36% are Asian, and only 0.6% are Native Americans. So if you are worried about diversity in your college, of course, that can be a good way to express importance of those values. So, so once again, we can express our numbers with tables, pie charts, bar charts, and in some cases on, using Pareto charts. So we are gonna cover this more in depth next time. So this is also very important. So we are going from the concept of statistics. We know that we have two branches of statistics. So also we know that we have to pay attention on populations and samples. So when it comes to samples, how can we choose the samples? So we were saying a few minutes ago that a good sample is a sample that is randomly selected. So, so sampling is a very important topic in our study of statistics. So gathering information about the entire population often costs too much, and it's almost impossible. Even, for example, the census. Census in the United States is a collection of a very big sample. So it's impossible for the government of the United States to gather information on 320 million people. So very likely samplings and big samplings that are highly scientific are going to be chosen to do the census. Of course, the size is going to be very big. So, so we're interested in doing some study. As I mentioned before, I want to know which group is bigger at Lehman. I'm gonna probably sample Lehman's population, and I'm gonna use certain criteria. So because gathering all the information is gonna be very costly, right? Unless I can have access to the records in the school, which are private. But anyways, so a sample should have the same characteristics as the population is representing. So we have to be careful when we are choosing our subjects in that particular sample. So there are many ways to do sampling. So, and the goal is to produce a random sample. So we have this simple random sample. So you have a bunch of people and everybody, like for example, a Lehman has the same opportunity to be chosen from that particular sample. So in some cases, I can ask, I can use a computer to generate random numbers. For example, Lehman population has let's say 10,000 students. So I cannot survey the 10,000 students. What I'm gonna do is I'm gonna choose a random sample, and I'm gonna generate a computer program that allows me to choose among the 10,000, probably 500. And among these 500, I probably will say that it's gonna be a representative sample. So I can also go to the roster, I can go to the registrar's office, and I am gonna choose like the 100th person in the roster until I fill my 500 subjects. So there are many ways to choose a simple random sample. So that simple random sample, as I said before, each sample of the same size has an equal chance of being selected. So, and that is very difficult because, like for example, what I mentioned, you have the big roster of the college, and you choose the 100th individual in that roster. So probably that is going to be randomly selected, which is going to be good. So, so there are many techniques to randomly select a sample. So also we have some other methods. For example, if I am studying smoking, so probably I don't want to make a random selection. Probably I'm more interested in gender differences. I might be interested in regional differences. For example, if people in Manhattan have more income than people in Queens. So I can do certain type of studies that allow me to do that. So, so that means that a random sample a simple random sample might not be the best thing I can do. Probably I'm gonna do either a stratified sample or a cluster sample. So the stratified sample divide the population into groups called strata and then take a proportionate number of each stratum. For example, I want to measure the effects of, let's say, smoking at Lehman College. So can I do everything at once? Well, probably not. So probably I'm going to stratify. So I'm going to take a group of my college population by department, and then choose a proportionate sample, simple random sample from each stratum. For example, I'm going to do the academic departments, and I'm gonna use, for example, 5 from economics, 5 from chemistry, 5 from every single department. So I'm gonna be stratifying my data by departments in the school. So stratified samples are very useful. So that helps you to, in some ways, overcome the problem of bias. So, and I think I'm running out of time. So, so let me just mention some things, if you allow me 10 more minutes. So we have these stratified samples. So we are dividing the groups and stratas. For example, I want to measure smoking. Probably measuring smoking is going to be difficult because there are, as I mentioned, gender differences. So I'm going to choose men and women, and then I am gonna assign different experiments on those. So the cluster basically means I'm gonna divide the population into groups. So for example, rather than going by departments, I'm gonna take the natural and social science division. So that's gonna be my cluster. So I'm gonna choose randomly among those, that particular cluster. So in the two cases, I can make some inference on the results. So, and this is a very good sampling method. So let me see how much, okay, not too bad. So, so we have also the systematic sample. So we have a convenient sample. So you can probably see this more on your own. So the systematic sample is what I was mentioning. You have a roster. You choose the 10th, the 100th, the 20th. It's like having the phone book that happens in the old times. You want to do a population sample. You take the phone book, and then you choose the 10th, the 100th, the 1000th person, and choose as many as necessary in order to produce your sample. In some cases, you don't have enough money, you don't have enough resources, you are short on staff, so you are going to perform a convenient sample. So you go to a place where you know people have, like for example, you want to analyze quality of life among people with HIV. So you go to an HIV clinic, that is a convenient sample. So you invite people to participate in your study, and you can do that. So there are many sampling methods that we can mention. So some of them are going to be with replacement, and some of them are going to be without replacement. So we have to be very careful about that. So who determines that? Very likely that's going to be determined by the scientist who is performing that particular experiment. So, and of course, there are so many mistakes that we can incur in. So producing a sample is extremely difficult. So you have to have a very big knowledge on how to produce a sample. When you analyze data, it's important to be aware of sampling errors and some non-sampling errors. So if we have errors in our sampling process, very likely our results are going to be biased. And that is not good for our experiment. Just imagine you are analyzing, and that is one of the critiques that people were saying about the COVID studies. Some people claim that, for example, the hydroxychloroquine is a bad medication. So people say that some of the results were based on biased samples. So we don't have enough information. So we have to make sure that the sample has been chosen in such a way that if you are performing an experiment, you have the experimental group and you have the placebo group. So, so that is very important. Sampling is going to be one of the sampling errors. So this is something that we need to pay attention on. So, so we need to evaluate the statistical studies. We read about, so it's very important because most of the times we receive information and that information might not be the best information. So there are some problems with samples. So most likely in order for the study to be at the highest level of experiments, so it has to be, the sample has to be representative of the population. For example, you are analyzing COVID. Do you have enough men, enough women? Do you have enough representation of different age groups? So that is very important. And it all depends on the nature of your study. You probably don't care about gender differences, but you care more about age differences. So in that case, you are setting the parameters for your study. So a sample that is not representative, of course, is going to produce biased results, results that are inaccurate and are not valid. So in many cases, it's very convenient to self-select samples. You send an announcement and you say, those who want to answer this questionnaire, they are gonna get $10. So in order to collect people, you give away $10 so people respond, but they don't provide enough information that can be useful. So in many cases, these self-selected samples are unreliable. So also there are many issues with sample size. We know that sample size, the bigger the sample, the better. But still we can have small samples and perform a very good experiment. For example, pilot studies, if you know how vaccines are created, so you start with a very small group of people. You are testing that the medication is gonna be non-toxic. Then you test it in a bigger group of people to see whether those affected are not going to have side effects and the intention of the medicine is the correct. And once you prove this in very small people, in very small group of people, you expand this to a very big number of people. So those are the steps of the clinical trials. So in many cases, and in all these cases, the sample size is always very, very important. So we are going to talk a little bit later on. So, and there are some other issues undue influence, like for example, if you go out and say, I'm a political scientist and I want to know how much President Trump is not good for people. So are you gonna ask the person, hey, mister, do you hate Mr. Trump? Of course, that is an undue influence. You are almost expecting the answer for that. So in many cases, questions have to be valid and have to be tested that they produce the outcome that you want. So, and some people, you invite them to participate, they don't participate. So those refusals to participate can be bad for your study. In many cases, people who are running studies, they have limited budgets. So this concept of casualty is also very important. In many cases, we say A causes B, but that's not exactly what we are going to be analyzing. Basically, we're going to be analyzing that every time A happens, B also happens. So there might be a relationship. It's not that the A causes B, but I can notice that when A changes, B changes. So causality or causality is going to be something that we are going to try to avoid in many cases. More than cause effect, we're going to be looking at relationships. And I'm getting very close. So we have many other cases. I just want to mention this case. It's very important, confounded. So in many cases, you say A is related to B, but actually A is not related to B, it's related to C. So for example, so one of the examples I put in class is that people eat ice cream, but also people die of drowning during the summertime. So of course, the number of ice cream consumption or the amount of ice cream consumption does not relate with drowning. So probably you can see the numbers that are moving together, but they are not related. They are related with the heat. So every time the heat is higher, of course, people eat more ice cream, and people also like to go to the beach, and therefore some people might die. So confounding is very important. In many cases, A is related to B, but is explained by C. So we need to make sure that our relationships are accurate. So almost finally, and I'm gonna wrap this up in 5 minutes, and I appreciate your time. So we have 4 different levels of measurements. Nominal scale basically deals with numbers, with labels. So we cannot do almost anything with this kind of data. So nominal is mostly qualitative, and it implies labels in my data. I can say ethnicity, whites versus African Americans. So that is one level of measurement. Is basically qualitative and is related to the labels of that particular information. We have also ordinal level, ordinal scale level. So we can order that from the highest to the lowest or vice versa. That's all we can do with the data. For example, we have the top 5 shows on TV. So you have the first, the second, the third, until the 5th, right? So they are numbers. They are names. Dancing with the Stars, 60 Minutes. So you cannot do anything but order them by the audience. So we have the nominal that is labeled, the ordinal that you can order. We also have the so-called interval. So that those are also type of, an example is the following. You have years, for example, from 1990 to 2020. So what can you do with this? Well, all you can do is order them from the highest to the lowest, right? So, but you cannot, even though they are numbers, you cannot perform any operation. You cannot say that 1990 is the double of 2020. So that makes no sense. So the interval scale measures values between 2 different points. From 1990 to 2020, there are 30 years, right? So that's the interval. So finally, the ratio basically means that you can perform any operation. You can order them from the lowest to the highest because they are numbers. You can take the mean, the standard deviation, you can take anything. So the ratio level is the more complete level of, in the scale, is the high, it comprises almost everything. You can perform numerical operations, you can order them, you can do many things. So I'm not spending too much time in this because I'm also running very low of time. So next time, I'm gonna start very quickly with the frequency tables. So, so we are gonna be building relative frequency, the cumulative frequency. So those things are things that we're gonna do. So finally for today, so we were mentioning some things about sampling. So sampling, also part of this analysis is the experimental design. What are the steps that you need to create an experiment? And experiments basically are what, let's say, pharmaceutical companies do. They want to know how effective, let's say, Lipitor is. So they choose 2 different groups. One that is going to be taking Lipitor, the other one is going to be taking what is called the placebo group, the placebo. So they measure many things in those groups and they compare the results. So, so those experimental designs are gonna be very important in our case. So I wish I could say more. Probably next time I'm gonna come back and mention some of these things. I really want you to be aware of all these topics. So just finally, I just want to do something very, very quick. So if you have your if you have your if you have your Excel file, so please click. So we are going to create very quickly a pie chart. So so the way we do it, we click, we highlight the numbers and the data. So we insert a chart, and in this case, I want a pie, right? So it's very simple. As you can see, the pie is created in less than 2 seconds. I can right click and I can say add data labels, so I can see the numbers. I can even format the data labels, and I can change them by percentage. I don't like the numbers, probably I like the percentages. And I want the category be on top. So as you can see, we did it in just a click. I highlighted these numbers. Sorry, I go to insert. You have to see how your Excel, if you have a Mac or you have a PC. So in this case, this version of Excel, I have to go to insert. I go to pie chart. So I'm creating the second. So I can compare them side by side, or if I arrange this information as I did here, so I put the full-time, the part-time, the two colleges. So I'm gonna highlight them. I am gonna insert again, and I am going to insert a column chart. So that's gonna reproduce what we did in the book, or what the book did. So we have the two different charts by full part-time and full-time in the two different colleges. So I wish we had more time. I don't like this 1 hour and 15 minutes class. I think it's too short. Do you guys have any question? Do you guys have any question? One question over here. No, okay. So, yes, please, Moises.
So for the homework, do we have homework every night or?
That's a very good question. As you can see, we have the first deadline. So the first deadline, that's a very good question. So let me pull a calendar. So this is tonight. So we have 2 more classes, and then this is August, this is September. Chapter 2 and 3 are gonna be due on September 17th. So you have almost 3 weeks to complete 2 chapters.
And this is on the sample thing, right?
It's the sapling learning thing, yes. So you have the test, and you have the problem sets in sapling. Once again, you have 3 chances in sapling learning for the problem sets, and for the exam, you should have only one chance. So make sure that when you open the test, you are prepared for that, okay? So the first problem set is gonna be due on September 17th. So the 18th and the 19th is gonna be so one of the holidays. I don't remember exactly, Rosh Hashanah. So many people take, I mean, it's a holiday. I should not provide any, so I should be respectful of those days, and I am. But still, the deadline is the 17th. I just want to announce to everybody that for convenience, sapling learning and Blackboard are gonna be open until the 20th, okay? The official deadline the 17th, but in this case, sapling learning and Blackboard are gonna be open until the 20th. And this is to show respect to the holiday that we have to observe. Okay? So any question? Did I answer your question, Moises?
Yeah, you did. Thank you.
Oh, no, this is Hamidou?
Yeah.
Okay, Hamidou, sorry. So, okay. So, so yes, please start reading the book. I'm gonna be sending the PowerPoints as soon as I edit them. Some of them are very basic. So, and some of them have so much information. I'm trying to condense them in a better way. So probably by the beginning of the next week, I'm gonna send the PowerPoints in advance, and I'm gonna send an Excel file, which is bigger. So we are gonna be working on this during the next couple of days. So please stay tuned, okay? Any other question?